Hi everybody, today we are going to discuss about the speed control of DC motor using the three-phase rectifier. Okay, so this is the rectifier panel because the supply is AC supply. The supply is AC supply is given to this rectifier to convert AC supply into DC supply. Okay, first of all, I vary this voltage. The voltage is, I said the voltage is 230 volt. You see the 230 volt varying. Slowly varying the tapping up to 230. Just see the 230 volt. Okay, exactly 230 volt. This is a DC rectifier panel. Just you have to set that 230 volt here. Okay, this both connection I give for this field winding of the DC motor, because in DC motor there are two types of winding. One is called field winding, and is called armature winding. So the field winding is excited by separate DC source, because it's a separately excited DC motor. They give it a separate supply to the field winding, and then the armature connection is given for this here, this module, three-phase SCR module. This is the three-phase SCR module. Okay, so I give the connection here G1 to G1, because in thyristor it has three terminals. One is called gate, cathode, and anode. So I give the G1 to G1, K1 to K1, G2 to G2, K to K2, G3 to G3, K3 to K3, G4 to G4, K4 to K4, G5 to G5, K5 to K5, G6 to G6, and K6 to K6. Because it is a thyristor to convert the AC supply into DC supply by varying the firing angle. It is called gate pulse. Okay. So I just switch on here MCB. What's the first procedure? You have to on the supply here, and then switch on the MCB and switch on the power supply. This is the first procedure to control this module. First, this is the three-phase auto transformer. You see, this is the three-phase auto transformer. Okay, I slowly vary. I varying this auto transformer up to, for example, kept a 60 volt. Okay. Next step, we have to switch on the supply. Switch on the supply here. So in this controller, you have open loop as well the closed loop. There are two modes. Okay, open loop and closed loop. If you want to check the voltage in the auto transformer, just click here multimeter. You see this multimeter. One phase, they give it one phase, R phase to B phase. You see the voltage. Approximately, you have 300 volt. Okay, I slowly vary the auto transformer here. Now you check the voltage here. Now you check the voltage. Okay, around 230. Okay, so next step we have to run the DC motor. This is the experiment. This is a speed control of DC motor using rectifier model. Okay, so the open loop. First on the open loop here, you see the open loop mode. There are two configurations. One is called set angle and axis, because you see the motor. This motor is not connected here, because we take the output in this sensor. Speed sensor is connected to the speed sensor is connected to this controller, and this from the external, from the controller to the here PWM output. Okay, so first set angle is given, and then voltage also given this module. Next step, we have to run the DC motor. So switch on the pulse. For example, set the angle is 180. Slowly vary here. Slowly vary up to 160, 150. Slowly vary up to okay, 114. Okay, now switch on the pulse. Now you check the motor is running. Now you check this motor is running condition. Usually the speed is not fed back to the controller. Now the speed sensor is fed back to this controller. Okay, now we check the angle here. You check the read on the check the angle. Set angle is 114. The actual speed is varying because the voltage also varying. If you want to note the armature voltage, just find here. Just find the positive and negative. Positive and negative. See the voltage. This voltage approximately you have 165 to 157. Just so the voltage is varying, because the voltage is varying means the speed also varying. So at the angle 114, the actual speed is approximately 1450. So now you increase the set angle. Now you increase the set angle value. For example, set the value is 140. The actual speed is, when you increase the angle, the actual speed is decreasing. When the speed is decreasing, the voltage also decreases.